In this video, we're going to talk through several examples where you have friends that are randomly assigned to sit in chairs that are in a row and in a circle. So starting with, you have 3 friends that are randomly assigned to sit in a row. Okay, so the row contains 7 chairs. So 1, 2, 3, 4, 5, 6, 7 chairs. And we want to know what's the probability that the friends sit next to each other. So the probability friends sit next to each other. Okay. So first, I think it's easier to think about the denominator, the total number of ways that the 3 friends can be assigned to sit in these 7 chairs. So we have 7 chairs. And basically, we need to figure out the number of ways that 3 people can be assigned to 7 chairs. All right. This is basically selection without replacement. And the order that these people are sitting in these chairs doesn't really matter, right? We just care about whether or not they're going to sit next to each other eventually. So we don't want to use a permutation. We want to use a combination, right? Where you have the order of them sitting in these chairs, it's irrelevant. Okay, so we have 7 chairs and we are choosing 3 for the friends to sit in. Okay, so what about, so how many ways in the numerator, we need to think of how many ways can they sit next to each other in this row. So let me see. They could sit next to each other if they're assigned to sit in these 3 right here. They can sit next to each other, let me use a different color, if they're assigned to sit in these 3 right here. They'll sit next to each other if they, let me use a different color, if they sit in these 3 chairs right here. They will sit next to each other if they sit in these 3 chairs right here. And lastly, they will sit next to each other if they sit in these 3 chairs right here. Okay, and that's the total number of ways that they can sit next to each other. So how many ways was that? There's 1, 2, 3, 4, 5, right? There are 5 different ways that the 3 friends can sit next to each other. So that's 5 in the numerator. Okay, in general, the total number of ways you can sit next to each other would just be the number of chairs, right? And then once you get to the end, you see I couldn't say there were 6 because I ran out of seats. So it would be the number of chairs, to say n is the number of chairs, minus the number of friends that you have. So say k. We have 3 friends. That's 7 minus 3, and then plus 1 because the first chair also counts. So 7 minus the 3 friends plus 1, which is 5, right? You can also just, like I said, just kind of count through it and think it through, by just seeing how many ways that you can sit together, right? But if you have much, much more chairs or more friends, then in general, this is the formula of how you arrive to that 5 here. Okay, so now how do I calculate this? Let's see, we would have 5 in the numerator. In the denominator, we have 7 choose 3. What is 7 choose 3? That is 7 factorial over 3 factorial, 7 minus 3 factorial, right? So that is 5. Let me go ahead and scroll down here so I don't have enough room. So that's 5 over 7 factorial, 3 factorial, 4 factorial. 5 over 7 factorial, well, that will cancel. So I'll have 7 times 6 times 5. And then if I have times 4 factorial, that'll cancel with that 4 on the bottom. So then I'll have 3 times 2. Okay, which is 3 times 2 is 6. So that's 6 cancels. And you're left with 7 times 5. The 5 cancels, right? And so you're left with, what is this, 1 over 7. Okay. All right. Let's see. Making the problem slightly more difficult is when you have the chairs in a circle. It's really not that much more difficult, but just slightly. So let's go ahead and draw out my 7 chairs. So 1, 2, 3, 4, 5, 6, 7, right? And so now I want the 3 friends to sit together in a circle. Okay. Once again, you just kind of have to think through. So, well, let me go ahead and first, right, so we were trying to find the probability that the friends sit next to each other. Friends sit next to each other. In a circle. All right. The denominator, again, we still have 7 chairs, and we are choosing 3 of them. So the harder part is the numerator, right? How many ways can these 3 friends sit next to each other? So they will sit next to each other if they select these 3, right? They will sit next to each other if they select these 3. They will sit next to each other if they select these 3. Okay, and you might see the pattern and be able to figure out what this is going to be. Oops, I missed one. So let's see. These 3. Okay. Then we have, what do we have? Then we have these 3. And we have, so I just did this one, so now I do this one. Okay. So basically every chair gets to be the starting point. Okay? Every chair gets to be the starting point, and then I get to pick the next 3. Right? That's basically what I just did. Every chair gets to be the starting point. So that means that there are 7 total ways I could have made that happen. Okay? Every chair was the starting point, so there's 7 total ways that the 3 friends can sit next to each other. They can either start here, right, and select this one, this one, this one. They could start at the second chair and have sat in this one, or this one. They could start at the 3rd chair and have sat here, here, here. They could start at the 4th chair, right, etc. So every chair gets to be the starting point. So that's why we have 7 in the numerator, 7 different ways that the 3 friends could sit next to each other, right? And then once again, we can just solve this now. Using our formula for combination, 7 factorial, 3 factorial, 7 minus 3 factorial, 7 over 7 factorial, 3 factorial, 4 factorial, and we know that, let's see, 7 factorial is 7 times 6 times 5 times 4 factorial, and we have 3 times 2, right, that's 3 factorial times 1, and then times 4 factorial. These guys cancel. This is 6, which cancels with that guy. The 7 cancels with that guy, and I'm left with 1 over 5. Okay, so the probability of sitting together in a circle is higher than the probability of sitting together in a row, right? And in general, this numerator here is just going to be however many chairs you have n. Right? When you're in a circle, it's a little easier to figure out the general case because every chair gets to be a starting point. So there are n number of ways you can make that happen, which is the total number of chairs.